So hello all, and once again, a warm welcome you all to this presentation. My name is Harsha, and I'm together with my two other colleagues, Alberto and Luis. I operate as head of text analytics within a Merck central function called as a Merck Data and AI organization, and we are responsible to drive a central data analytics and AI strategy and to deliver an ecosystem for the whole organization. Alberto and Luis operates in an adjacent function, and they are responsible to they work in the stream of data science and use case delivery. And Alberto operates as a senior data scientist, and Luis operates as a data and analytics architect. And today we have an interesting solution to be presented. It's called as a CONAN, which is enabling and expediting the legal experts and lawyers in the organization to efficiently find information within the contracts using the concepts of NLP and AI in the background. And before we go to the details, we can have a quick look into the organization. So Merck is a vibrant science and technology company. It is headquartered in Darmstadt in Germany, and we are called as EMD Group and in US and Canada. And established in 1668, so Merck is one of the oldest pharma chemical company on this planet. And we are into three areas of business: life science, healthcare, and electronics. In life science, we offer products and services to cater the needs of diagnostics, biotech, and other life science industries. In healthcare, we produce medicinal products and medical devices for the quality of to improve the quality of life of patients and end consumers. And in electronics business, we offer digital products, materials that caters the needs of other electronics companies. And when it comes to the applications of artificial intelligence and NLP within the company, we have found a successful applications of NLP across the end-to-end value chain. If you look at it more from a research and development point of view, more from the testing phases of the product in terms of manufacturing, regulatory, post-market surveillance, and so on and so forth. We have found NLP has delivered a successful applications across end-to-end value chain. So if I take an examples of research and development, so here NLP is typically applied to help researchers and scientists to find valuable information or relevant information from sources like publications, like patents, and so on and so forth. Then in the development area, we speak about examples like clinical trial analysis, patient-focused drug discovery, where we try to analyze clinical trial information or the information from present in the social media to understand the experiences of the patients, experiences of the customers, and so on. In the manufacturing area, we try to analyze the manufacturing deviations so that we can improve our quality processes to improve the overall manufacturing processes end to end. And then when we speak about customer facing organizations, for example, here we speak about customer inquiry analysis, analyzing the interactions that happens between healthcare professionals and medical science liaisons so that we are able to understand the unmet needs of the customers, unmet needs of the patient, so that we can improve the quality of services and products towards them. And the focus for today is NLP for legal. Here we apply NLP to analyze the contracts, to digest the legal contracts, to help our legal experts and lawyers to be able to find relevant information within the contracts for their day-to-day business. So with this, I pass it over to Luis to take us into the details of this use case.
Yes, so thank you, Asha, for introducing us and the company Merck. Now I will go deeper into our use case, CONAN Contract Analytics. So what was the problem statement that business had when it came or it had the idea of this use case? The problem statement was pretty much, how can we respond quickly to aggressive changes in the business environment, or how can we assure business sustainability? And you might be asking, what does the legal department have to do has to do with that? The Merck legal department is responsible for providing insights to the business on whether the responses to these aggressive changes require changes to contracts. So what the business needs is pretty much a tool, because going through all of these contracts, every time there is an aggressive change that you have to respond to quickly, manually takes very much time and is prone to error. So this tool should have the capabilities of smart search and text processing. It should be tailored to the lawyer's work style and agile, so that if there are new search features required, these can be quickly implemented. And of course, it should be secure, because there is very sensitive company information inside of contracts, which should not be exposed outside, for example, for training purposes of an external NLP model. Now, let's look at a scenario here. Our legal colleague now got the request. There is an aggressive change, and our legal colleague needs to search in the contract for something. This something could be, how confidential is this contract? Or does the contract allow price changes? Or are we allowed to sell this product in Europe? It would be contained by clauses. The three clauses that I just provided, or the three questions that I just provided, address three clauses: data privacy, price increase, and exclusivity. But there is pretty much an unlimited amount of clauses that you can imagine. It's just about how the content looks that you search for. And the tricky thing about these clauses is they are not so obvious to find. For example, here we look at the price increase clause. It is just hidden inside of the text. And if we read through it, in the event of a significant increase in the cost of raw materials exceeding 10% or more, we can see you have to have an understanding of what a price increase is to realize that this really is a price increase clause. Firstly, this means that there is quite some effort behind it for a user to identify this clause manually. And also it makes the algorithm that we implement more interesting. Here is another example. The exclusivity clause, also just hidden inside the text. Furthermore, both parties agree to an exclusivity arrangement, and so on. Now, if the lawyer or the legal colleague in our department has to find all of these clauses by himself, he's not so happy. Because, there are very many contracts. Contracts are very long, normally between 20 and 50 pages, and the clauses are hidden inside the text. So identifying clauses manually is a huge effort and also prone to error, which is the reason why business decided they want to have an application where they can just put in a keyword like exclusivity. This would be the clause that we are now looking at. Conan was already trained to understand what exclusivity means. And then with this understanding, it goes through the documents and can say, okay, I'm confident this is what you're looking for. Here I found a text snippet. Or not so sure, but I found at least something. Or, I don't think that this clause is contained by the document. So what we want to provide is the clause in case it was found and some kind of confidence that the application has in its prediction. Then, if this works correctly, the user saves time and also has the option to get insights on demand. So now, Alberto, how were we able to implement this?
Oh, you, Luis. Yeah. In order to create a system with the capabilities to extract the right information, we rely on the idea of semantic similarity instead of a keyword matching. A keyword system will look for exact matches and usually offers at the end rankings depending on the number of exact matches that is able to detect. This may be useful if you know exactly what you are looking for. For instance, if you are looking for serial numbers or product names. However, when searching through content written by people, you want to capture the nuance of the language. In the context of this task, the system needs to go beyond a keyword matching. It needs to understand the terms and be able to connect and relate these terms. To achieve this objective, we use vector representation, which maps words to high-dimensional vector spaces. These representations are learned so that words representing similar concepts are close to each other in the same meaning bubble. They represent conceptual similarity even if those words have no lexical or spelling similarities. Next, Luis. The next step is stop thinking about words and start thinking about sentences, paragraphs, or even documents. Here, transformers enable us to think about semantic search in a broader sense. In that sense, we are leveraging pre-training models to correctly obtain the semantical representation of sentences, paragraphs, even documents from legal contracts, along with the query, which is the essence of the information we are searching for. At the bottom, if go to the next one, please. At the bottom of the slide, we present a possible example to detect price increase clauses in legal contracts. Next. how we are building these queries to detect and extract all the necessary information. Currently, this process involves a semi-manual, um, uh, mainly a human intervention with generative AI. We go through an offline pipeline to generate and evaluate the query. CONAN is providing pre-designed queries with high confidence results to the users in order to reduce the confusion for mainly non-technical users in the early stages of the product. At the end, at the end of the process, the system ensures the quality of the extraction. However, in the long term, we expect to semi-automate or even fully automate this process through a new layer of models. Next slide. One of the main points when building, selecting, or training these kind of models is the difference between symmetric semantic search and asymmetric semantic search. While symmetric models expect entries that are about the same length, we could potentially flip these entries. Asymmetric models have shorter queries for longer extractions. In this case, flipping the query and the entry in the corpus doesn't make sense. When searching for legal clauses, agreements, chunks of information in legal documents, we expect longer answers than our queries. And this is reflected on the performance of the symmetric and asymmetric models. Our final evaluation shows a better performance of asymmetric semantic search models, and that's why we are using them. Next slide. Thank you, Luis. Before feeding our models with the data, the system goes through a pre-processing process that involves extracting the data from legal documents, mainly PDFs. And one of the main challenges is the variability of the formats and forms in legal contracts, not only over the years, but also of the subjects. We found several corner cases with scanned documents, machine-readable text, as well as mixture of both. And as in many other NLP problems, we go through a cleaning process, removing all non-relevant information, such as signatures, headers, footers, and every information that is not related to the task or the clauses that we want to extract. Finally, the text is split to then create blocks of end sentences. The core of CONAN is following an extractive approach. So the creation of blocks with the correct length is a key part of a successful system. Not breaking the clauses in the middle of the formulation or including unrelated topics in a clause is an objective that the system pushes as far as possible. Due to this reason, the number of sentences in each block is dependent on several factors, such as the clause. Finally, once we process all the information, the model generates the numerical representation of the vectors, and the system yields the ranking with the extractions based on a cosine similarity between blocks and the query. Therefore, we have our final results. However, we need to take into account that we may have overlap between answers due to the approach that we have, or due to the approach when we are building the blocks in our corpus. Reducing the redundancy of the final answer is a must. So if we find consecutive overlap extractions, then we need to concatenate them. For each concatenated block, the final cosine score associated to it is the maximum cosine score of the group of extractions. That's because of we want to keep the order of the final ranking. Next slide, Luis. To exemplify the capabilities of the system, we would like to use the price increase clause as an example of the global results. By using the cosine similarity, we evaluate the extractions containing the correct answers, yellow bars, versus top-ranked extractions non-containing the clause, blue bars. We can see how these blocks of information are significantly separated, where blocks with the clause are in general much more similar to the query than the rest of the information. This is reflected at the bottom of the slide, where we are presenting the top 1, 2, 3, and 4 accuracy for the clauses that CONAN is currently serving. As a quick note, The error that we can see is not just produced by the model, but the OCR, when the extraction of the text is not completely done in some corner cases. So we need to take care of the accuracy recall of the model and the accuracy of the OCR. Therefore, we can understand the system as different pieces interconnected in order to process and fast retrieve information for the users. CONAN is currently hosted and running in AWS, so we can see a very high level diagram to see the flow of the information through the system. Using our offline pipeline, we can provide users with pre-designed queries where we allow the users to upload different batches of documents with different sizes to our platform. All this information runs into the OCR, is processed, and transformed into a numerical vector space. This part of the process is the most time consuming, taking into account that we are running the OCR for each document. After this, post-processing and retrieving the results is almost immediate. And the user will see the information in the CONAN user interface. Now I will hand over to Luis to do the demonstration.
Yes, thanks, Alberto. Now that we have gone through all of these NLP concepts in theory, let's look how they are performing in action. So this is our application that we have. In the beginning, we upload some documents. So these are just documents that the users have on their computer. And then the user can select the clause that is relevant for them. I'm selecting the price clause that was already given as an example in the introduction in the beginning. And now all of the processing begins in the backend, the AWS backend. All of the steps that Alberto just describes are being performed. And at some point, the response is given. And here you can see for all of the 3 uploaded documents, there were extractions that have a high probability of being the correct clause or the selected clause, so the price increase clause. We can also open an Excel list where we can look at these. So this is now exported for each of the documents with high confidence clauses. We now have them in the Excel list, and we can also look at it inside of the website. So here we can see this is exactly the clause that we were searching for. If we want to look at one document specifically, we can do this in the result details section. Here we have the top 3 picks of clauses that were searched for. Here on the left, you can see this one only has a medium confidence. This one has a high confidence of being the correct clause. And if we want to jump more into the document and understand a little more about what is there, we can also do that with a PDF viewer. If we have finished that, then we can just create a new request. All of the rest is now being deleted. And maybe we want to analyze additional documents, or we search for another clause. Here on the right, we click on request results, and the whole process starts again from the beginning. Right. And with that, I hand back over to you, Alberto.
Thank you, Luis. So pre-designed queries allow to familiarize with the AI, semantic search, and CONAN platform to the users at the same time that we provide high confidence results. Ensuring transparency to the users allows a more engaging experience with the platform, especially for the non-technical ones. In any case, we are not restricting CONAN functionalities. We are looking for flexibility and accuracy. So we will allow users to formulate their own queries. Moreover, we are in process of adding new functionalities. In this case, we will see the potential of large language models as a driver for new applications. The ones in these slides are not all the applications we are working on, but they are directly related to the tasks that we are trying to solve in CONAN. A way of adding flexibility while keeping the system in good shape is to build chatbots to converse with documents or vector databases. Same for the idea of contracts or clause summary functionality, or even for the clause detection. While CONAN follows an extractive approach, my GPT, which is the Merck internal ChatGPT integration, can approach the same function from a generative perspective by a good prompt engineering. Not only that, We enable the model to return a comparison between instructions where we can put more attention in several elements or details, such as duration of the contracts in each clause or the conditions of each clause. We can use these models to extract metadata too, such as parties, duration of contracts, execution dates, relations between entities, etc., with the objective of building knowledge databases or just basically to enrich the information. This is one of the most extended ideas, not just in CONAN. And at the end, we aim to enable agents in the platform to be able to perform several tasks connecting these agents to our different systems. This is part of our vision. In any case, I will hand over to Luis again for this topic.
Yes, exactly. So, as you now heard, there are quite some ideas we have for the future, and we somehow need direction how to handle this. And this is what I'm talking about now, our vision. First topic of our vision is the LeDocs integration with CONAN and some additional UI enhancements. For those of you that are wondering what LeDocs is, and I assume it is many people, LeDocs is the Merck internal contract management system, as you can see on the bottom right. So we want to integrate LeDocs with CONAN, which means people jump into LeDocs, they can look at their contracts, select them, and then from there get automatically forwarded to our application where they can get some analytics insights. The additional use case scenarios were just presented by Alberto. Of course, we have ideas about integrating more sophisticated AI and machine learning capabilities, but also in general, adding additional clauses is definitely something that is planned for the future. As of now, we only have 4, as you might have seen in the demo, but the options are pretty much unlimited here. Also, not only the legal function is interested in these clauses or additional capabilities, but also other functions inside of the Merck environment were already impressed by this application and wanted to know whether they can utilize it for their purposes. So onboarding of other functions is also planned for the future. And what we intend with that at the very end is to establish CONAN as the go-to app for contract analytics. Because contract analytics is definitely a legal topic, but it's also a very common use case in companies because we have many departments working with contracts, and sometimes understanding this, especially as somebody that is not a legal person, can be quite tricky. In the end, we want to have a fully automated, user-friendly, and seamless M365 to optimize interface for document analytics. M365 to optimize, what does that mean? M365 stands for LeDocs, because LeDocs is a SharePoint environment. And optimize, on the bottom right, we also see a disclaimer here, is the Merck internal data and analytics ecosystem. And this is where CONAN was built on. So the integration of CONAN and LeDocs together, and this in a seamless way, is our final idea about the capabilities. And going beyond the capabilities, we also want to continuously improve the user experience on our application so that it's, in the end, very easy for users to understand what's going on and to really establish this in their everyday work. Last but not least, this is our team. The technical team consists out of 5 people. 2 of these are data scientists. One of them you already got to know, that's Alberto Oteo Garcia, and Christian Hengesbach is the other one. The DNA enablement consultant, Natalia Smeljanski, is working in collaboration with the business to collect requirements and translate them for us, the technical team. And then the data architects, Daniel Steffen and I, Luis German, we are taking these requirements, translating them in designs or into specific tasks so that the technical team can work on them. Here we are also supported by 2 consultants that work in the cloud architecture area. So in the AWS environment, Johannes Amorosa and Nadia Fernandez are supporting us. And very important, the business is the people that, or the business are the people that initially had the idea of this use case, and that are definitely driving this beyond so that NLP at Merck is definitely also correlated with this use case, CONAN. And maybe not only at Merck, this CONAN use case has some relevance, but also in the general environment of companies, we can have this CONAN use case as something to show off. So Tibor Chilpe is the head of technology and processes for group legal and compliance, and Tony Geyer is in the same department as the project manager for technology and processes. And with that, this is the end of our presentation. I hope you were able to learn some stuff about NLP, or maybe even the company Merck. And all that's left to say is have fun with the rest of the presentations here at the NLP Summit. Thanks.